This is a Math 2 lesson summary video for the lesson entitled Pythagoras by Proportions. In Lesson 6, Pythagoras by Proportions, the purpose of this lesson is to use our knowledge of similar triangles to write proportions relating the sides of three similar triangles when an altitude is drawn in the triangle. In this lesson, we took a large triangle, right triangle, and we drew an altitude. The altitude of a triangle is also known as the height of the triangle. In the first part of Lesson 6, we are given an index card and we are asked to cut a 4x6 index card along one of its diagonals to form two congruent triangles. I'm now going to demonstrate these steps as we did in class using an index card.
So in the first part of this investigation, we took a 4x6 index card and we cut along the diagonal. And the diagonal would be this long diagonal from vertex to vertex. So that was step one. Then this created two separate pieces that had two right triangles. We were asked to then draw the altitude. So we took a pencil or a pen and we drew an altitude here. And then we took our other triangle, which at that point was not cut, and we drew the altitude here. Keep in mind, an altitude is the height of a triangle. It goes from a vertex to opposite side and forms a right angle with the opposite side. The third step asks us to label each triangle as shown in the following diagram. So we were given information in the book, and all we did was copy. Capital letters A, B, and C represent angle measures. The sides opposite are lowercase a, b, and c, and those represent the side lengths. So opposite big angle A is side length little a. Opposite big B is side length little b. And then in the book it told us to label these two sides x and y. So we're essentially just copying verbatim the letters and the variables that were given to us in our MVP book. In step 4, we were asked to cut one of the right triangles along the altitude. So that's what we did here. We took that altitude and we cut it, and it created two right triangles. We are then asked to arrange the three triangles in a way that convinces us that all three right triangles are similar. Well, we know that we can show similarity if we have two angles congruent, if we have three sides with the same ratio, or if we have two sides with the same ratio and an angle in between is congruent. So when we look at these three triangles, we don't have any side lengths. So we're going to have to figure out how to get angles to be congruent. If I place this smaller triangle on top of this larger triangle, what we actually notice is we can prove that those two triangles, of course, are congruent because that one came from that one. But now we need to compare it to another triangle. So let's say angle D is right, and so is this angle D. And they both have that same angle. So there's one pair of angles. Angle D is congruent to itself by the reflexive property. So those are indeed congruent. Now when we look at the original diagram, we need to get another pair of angles that will be congruent. Well, if I compare these two, I do notice that this was a right angle. So this letter C, and angle C, must be 45 degrees because that altitude is going to split that angle into two congruent parts. So therefore, these two right triangles will be similar by angle-angle similarity. Okay, so now let's look at the large triangle and the medium-sized triangle. So I have two right angles, angle C and angle D. Those are both 90, so those must be congruent. So now we need to figure out, is there another angle that will indeed be congruent? Well, if I go back to, let's see if we can get these two. If I coincide this triangle on top of this angle, or this triangle, we see that obviously the triangle underneath is congruent, but isn't angle A congruent to the angle A underneath? And so therefore, the large triangle and the medium-sized triangle will be similar by angle-angle similarity. And we can say that all three, if we compare any two triangles, they will always be similar by angle-angle similarity. So we have just talked through why all three of these triangles will be similar. Okay, so I'm going to put them in the same orientation now. All right, so the main part of this lesson now is to talk about what's important, now that we know that they're similar, don't we know that we can write proportions relating the side lengths? So for example, if I'm looking at these three triangles, and I want to now write some proportions, which asks us in step 6 to write some proportions that would represent relationships among sides, I can take a look at corresponding sides. So if I look at these diagrams, and let's just, for example, say, if I'm looking at this big one, and then I'll compare it to the little one. So we need to use corresponding sides. So if I want to write a proportion, I could say that this side length, little b, divided by its corresponding side over here, which would be little x, should be equal to, and we can choose any other side. If this is opposite big C, this whole side we can call little c, so we can use that side, or we can come over here and say little a over little b. So there's one proportion that we can write that would actually relate these two triangles. And there's many proportions we can write. If I want to compare the medium-sized triangle with the larger triangle, I would look at corresponding sides. Now this side was labeled B. I also labeled it H, just so you could see that that is the altitude or the height. So it doesn't matter if you use the little b or the h. I'm going to go with just the h, I guess, in this case. So we could do h, which is this side length, over x. And that should equal, and you could choose any other side. Let's go this side, b over a. Okay, so there are many proportions you can write. Using our prior knowledge on similar triangles, we know that we can write many proportions. So then we looked at some specific examples.
So in this specific example, given in our MVP booklets, we can see that an altitude is drawn. And in this case, the altitude has a length of 8 units. So now we need to figure out the values of x and y. So if we recall from the activity from class, we know that when the altitude is drawn in a right triangle, it creates 3 similar triangles. So we can write a proportion, cross multiply to solve for the missing length. So what I've done here is I've taken each of these triangles on the left, and I can highlight them for you. So in green here, this is the smallest triangle, and I've drawn the green triangle over here. The shortest length, or the shortest leg on that triangle is 6. The longer leg is the altitude, or 8, and the hypotenuse is y. So if we look at this triangle, we already know Pythagorean theorem. 6 squared plus 8 squared will give us y squared. So we know that we can find that missing side length by solving for y. And the square root of 100, y should be 10. We also call that a Pythagorean triple, 6, 8, 10. So now that we found those values, let's look at the rightmost triangle. I'll highlight that in blue. So that rightmost triangle is here. Again, the altitude is 8. Now, it gets a little tricky because I know the whole length of this side of the triangle is x, and I know this piece is 6. So to find this length, I'm going to have to write the expression x minus 6. The whole length minus 6 should give us the length of the question mark, the side length on the blue triangle. And we don't know the hypotenuse on that one. And then the larger triangle will have a short leg of y, a hypotenuse of x minus 6, and we don't know the long leg. So we're trying to find x and y. Well, if I compare this triangle to this triangle, the question is, do I have corresponding sides? And I do. If I look at these two triangles, I can see that I do have 6 is to 8. Those are corresponding sides. So 6 is to 8 as 8 is to x minus 6. So we can write a proportion, and the next step will be to cross multiply. 8 times 8 is 64. 6 times the quantity x minus 6. You can distribute the 6 or you can divide by 6. It is your choice. I'll just distribute the 6. So 64 equals 6x minus 36. I'm going to add 36, and I get 6x equals 100. Divide by 6, and my value for x will be 50/3, or 16 2/3, or 16.6, repeating. So I found x and I found y. If we scroll up on that page, the two theorems that are important for this lesson are listed. The first theorem is the right triangle altitude theorem 1. And that theorem tells us that if an altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the lengths of the two segments formed on the hypotenuse. The second theorem, the right triangle altitude theorem, number 2, says that if an altitude is drawn to the hypotenuse of a right triangle, the length of each leg of the right triangle is the geometric mean between the length of the hypotenuse and the length of the segment on the hypotenuse adjacent to the leg. So if we're looking at this diagram and we use the information about the geometric mean, what that is saying, that theorem, is that this length here, the 6 over the altitude should always be equal to the altitude over this length. So the 6 over the altitude, or the height, should always be equal to the height over the other long leg, which was x minus 6. And if you notice when we did the math, that's exactly what we did. And that will always work when you're trying to solve for the altitude. If you need more help on the Ready, Set, Go homework for this task, please check the Canvas Student Support site.